All right, hey guys, I'm back. We're gonna wing another one here. Things are getting stranger and stranger, I'm telling you. But just to confirm, once again, here we are. We're seeing this is the latest run on the GOES 16 as re as presented by the coloradostate.edu. And I didn't realize you could move this thing around, but nonetheless, I'm sure they still had it cropped out, or I couldn't see it down here yesterday, but unfortunately didn't get that chance. But it looks like pretty much the same pixelated cropping out feature they're using on today, so they really haven't changed this side up. But I mean, you could see how big this thing is. See if I could stop it. There we go. I mean, it's pretty big. But like I mentioned in last night's video, when I confirmed it on the Himawari 8 in the West Pacific, cross planet, same deal. That's a pretty big image, but I mean, can't really determine how close it is to the Earth or the GOES 16 satellite, which is at the 22,236 mile geosynchronous orbit point. See, there's the GOES 13 and 14. I think maybe these are the ones they're using to give all this space weather data in order to make up these simulations. And then you get the GOES 16 going around out here too, I guess in the Himawari 8. Any of the weather satellites, they're out here at this geosynchronous orbit, 22,236 or 238 miles, depending on your math. So, and I pulled it up on, okay, there it is there. Then just to show you, this is the same run, but it's on the Himawari 8 on the other side of the planet. Same time and everything, 10:18. You can see it's not showing up on this side, but I'm sure it will tonight. And just to show you one other thing, so I mean, this is published by coloradostate.edu, but it's still the GOES 16 satellite feed. Here I pulled up the actual GOES site, GOES East Imager, and you can see it's coming around just like it is on the whoops. Oh, that's pretty cool. Let's see if we can do that. Stop it on the image. Let's see if we can drag it back. I don't think it's going to let us. Okay, well, there it is. Now let's click on here, and it doesn't really tell us anything. Although you could see, oh yeah, well, so these square pixels are coming out, so you can see the lights behind them. So there's the actual image. You can see the roundness of it there. Let's see if we can get a better view of that. Okay, here it comes. Okay, so let's see what it looks like on this side, see if we can catch the other circular circumference part of it. So you can see that some of these pixelated squares are covering up blank space because you can see the planet showing through. But anyway, enough on that. That's not so. But point is, it's a government satellite. It's just different people accessing the data and presenting it. Now I pulled up same deal with here. This is the University of Michigan, but it's coming from satellite data. I think it goes, yeah, the geospace. So this is coming from the GOES satellites, I believe, that are doing the ISWA space weather data and so forth. See, it's from University of Michigan. It's a model they made up from using the data from SWMF, which is a government. It's government website. But look at this, man. Pressure. It's gotten even more equalized. I mean, we're showing hardly any type of a pressure reading here in this last 3 hour, 30-minute run. So, wow. This is getting pretty crazy, guys. So this is going on at least 36 hours and possibly 48. Because I think I've been checking this thing every day. Yeah, pretty sure. I didn't catch it till, well, you can see on my video. There's my latest video list. So I think this is the one I identified this pressure equalization current on the 16th. I think that was in the evening I made that video. So today's the 18th, so at least 36 hours. I may not have checked that geospace in the morning, but I probably did. I don't know if I seen this or not. I probably not, or I would have probably made a video. But anyway, there you got the pressure. It's the last 3 hour run. And unfortunately, this run doesn't begin until somewhere around, I think it's in 10 o'clock UTC. And I'm going to show you why I'm saying that here in just a second. Let's let it roll over. Okay, yeah, see 1007. There's the density. It's getting a little more spread, looks like to me. And of course the velocity, it doesn't really show you much. But here's why I'm saying, unfortunately it doesn't start until 10. Because check this out. See, I got it stopped on 17th, 1958 UTC, which that's last night around 7 p.m. UTC or around noon Eastern Daylight Time. And watch how much missing time there is. So we got it at 1958. And normally, I mean, the most missing time I've seen is about 4 hours. But this is on the 17th, last night. Then click at 1, goes to 18th to 10:44. That's like 15 hours of missing time. I mean, that's just crazy. And you see this huge discharge coming out when it comes back up, which that's usually the case. Let's click this one over. See 17, 1017, 1958. There's the discharge. And I didn't see a whole lot on this one other than, well, there's the discharge. I mean, prior to the 15 hours of missing time, well, you can see it's got a whole lot of backside pressure coming in. And I didn't see any other missing time other than maybe 20, 30, 40 seconds in a clip. during this period. But you can see all the backside pressure and the electron pressure. Now these things, they quit recording. They're only recording up to well, I guess they went pretty far. They went up to around 10. So, I mean, but I didn't really see anything crazy on these things, to be honest. But there's the missing time. So you can see it went up to 11, and then of course it rolls back to the next day. So, I mean, look at all the arrows. These are the arrows indicating solar wind direction. Of course, the sun's on this side. There's the lighted side. And so all the arrows always should be going this way. But as you can see, we got a bunch of arrows pointing back toward the planet. And all this blue stuff, that's some serious high plasma electron energy. And it's trying to come back to the planet. And the planet's trying to fight it off. So this is at 1017, 916. Let's see what it looks like on this. So you can see it's starting to buck up, getting these field lines closed to try to ward off all this. Look at that. All the arrows, they're pointing way out here. This is way out here. There's 1, 2, 3, 4, 5. So that's 6. And 7's turning toward the earth. So usually from watching it that I've been watching, the farthest back these arrows went facing the planet is maybe 2 or 3 deep. Now it's getting back toward maybe almost 6 deep. I mean, you can see that these black polar cap field lines, they're having to close and try to garner some strength from the Earth in order to fight off this plasma electron energy that's coming in. We'll put this one back to 916. So, I mean, look, you can see the energy trying to get in. The magnetic pause is getting buckled and crumpled up. And you can see the energy's trying to bleed in. So at 916, it's all around. I mean, there it is. Well, anyway, oh yeah, there's one more thing I wanted to show you. Okay, the ACE. Last night I pointed out that there was like a 3-hour gap. Maybe it might have been, I suggested it might be the moon. That big 8 or 9-hour gap that finally disappeared. So I figured it crossed the plane and it's not being recorded, not being blocking ACE anymore. Now look here today, we got 1800 to a little past 20. There's like 2.5-hour gap there. There's an hour gap there. And then we have 1, 2, 7. That's a 6-hour gap there. I mean, what? Would we have some more celestial objects coming in? I don't know. Then I'll check Discover. I don't see any gaps there. So like I pointed out yesterday, these two, although they're both parked, they're both parked out here at the L1 Lagrange point, which is 930,000 miles in front of the Earth, between the Earth and the Sun. Of course, this isn't to scale. Even though they're both out here at the L1 Lagrange point, as I pointed out yesterday in the video, they're not probably linked together or that close together. That would account for the gap on ACE and the no gaps on Discover. That's the best I can figure anyway. So bring you back to the there it is. I'm running out of time. I'll probably see you again tonight. God bless, peace, and I'm out.